Recording in progress. I missed that voice. So I was teaching from Ukraine one summer with a time difference. It was not too bad. I was teaching at 8 p.m. Class was at noon. And then the lady in the Zoom said, recording in progress in Russian language, and then in Ukraine also. So that was very interesting to hear that actually it can have different languages. I did not know that either. And the language and the voice was so kind. So like, oh, why the voice is so kind. Let's start with the ratio test. Ratio test will be a big part of the exam. I told you that before, it's not a secret at all. So sometimes we even put it in the free response part, but it's definitely everywhere in the ratio test, in the multiple choice part of the test. Ratio test says, find this limit of the ratio next term over the previous term, hence the title, ratio test. It checks the ratio. Absolute value, so we don't care about negative signs. If all the time at the end of those series, the next term of the previous term gives you the number, and this number is less than 1, then what? Do we know about that? Is in converges absolutely. Converges absolutely. If it's greater than 1, that means the ratio is getting bigger and bigger. What is greater than 1? It's 8 over 5, 7 over 3, 12 over 2. It's getting bigger and bigger. Well, duh, that means that blows up, which means diverges, including infinity. Infinity is also greater than 1, so that is also bad. So that means diverges. If it's 1, the inconclusive, some of you might have that on the test. Inconclusive, use another test. Use another test. So if I make mistakes, I'm not the evening teacher. That's why I never request or I deny actually classes in the evening because I'm not good at teaching in the evening. Let me know if I messed up and I say something weird. We can fix that. Examples. Let's work through several examples. Basically, I want to show you quickly 3 cases. And while we're on this topic, guess what? To practice factorials. That was my voice. To practice factorials and in general algebra. Most of the time, the hard part will be algebra. So just make sure you're doing well. The sum 5n plus 3, 5 to the n plus 2, all over 8 to the n is from 6 to infinity. Finally, if it converges or diverges, let's use ratio. That's called a power series. Let's use ratio test. Power series, for now, no x involved here. Solution. There's no actual steps here. It's just power series right away. Step 1, use power series. Step 2, conclude. What's the conclusion? So use ratio test for power series. And we're going to have limit of, and I'll write down, so I know it's going to be a huge fraction. So everywhere I see n, it's going to be n plus 1. I will make some mistakes on purpose, so you kind of like help me out with this. And 5n plus 1 plus 3. Everywhere I see n, I put n plus 1. 8n plus 1, parentheses, 5n plus 1 plus 2. And then the other one, I flip. That's the original multiplying by reciprocal. Okay, find the mistake. Put it in chat if you want, or just unmute yourself.
I already posted in chat.
Thank you. Good job. I did not check it. N goes to infinity. So make sure you don't make this mistake. And which is parentheses. Parentheses matter. Let me see what you said. It is so slow here.
What?
5n plus 1. Yes, good job.
I'm on my meeting. Or not the meeting, I'm on my
Caden.
For my exam tomorrow.
Yes, tell people not to bother you, Caden. Okay, so new job for the co-host is to mute people. I just muted Caden. So like that's actually very satisfying, surprisingly, to mute people. When I'm at a serious meeting and there's a professor talking and I just go and mute professor, it's very satisfying somehow. So n plus 1, n plus 1, n plus 1, everywhere you see n. Now you collect, that's not necessary. Now simplify the way you'll know how to simplify. I usually explain it this way, collect the terms that look alike, like 5n plus 5 plus 3. So I'm distributing 5 everywhere, that's important, or else the answer might be different. And then over 5n plus 3, these terms look alike. What else? 5 to the power look alike, n plus 3 over n plus 2. What's that was my handwriting? N plus 2 times 8 to the n over 8 to the n plus 1. And now you simplify whatever you can. Do not simplify sums and differences. Only products and factorials can be simplified. And products, quotients, factorials. This guy cannot be simplified. This will be solved with a limit. Others can be. So remember that if something is added or subtracted, you do not touch that. So I will just write down 5n plus 8. I can do this simplification, but no canceling. So if you do this, it will mess up everything. You don't do that kind of stuff. Times, now I have 5, n plus 3 minus n minus 2 is just 5. 8, n minus 1 to the minus 1, or you can keep it as 1 over 8. You decide, doesn't matter. Now we finally can hit the limit. The limit looks at this part, it gives you the answer. The answer is 5 over 5, the ratio of the leading coefficient. So 5 over 5, let me write down just in case. Then times 5 times 1 over 8. Give you some kind of number. Everything depends on the answer of what this number is. We don't care what this number in terms of how high it is or how low. We only care if it's greater than 1 or less than 1 or 1. That's it. But it's 5 over 8. Less than 1 converges absolutely. Absolutely. That's it. Then you do this on a test. So no other questions are asked. Also note, so let me make a couple notes for people not to be confused. Note, the original sum, let's call it A sum n, converges absolutely by the ratio test. Note 1. Note 2, it doesn't converge to 5 over 8. Doesn't converge to 5 over 8. It's a common mistake to think this way. That was just a test. Ratio test is a test, and it says less than 1 converges. But we don't know converges to what, and we did not ask you for a while, so don't be bothered by that. Only in upper level classes we go back to topics and ask converges to what. When they ask a good question, if L is 1, do we say it's just inconclusive, or we actually have to find it? Usually you actually have to find it using another test, but not in this case. In this exam, just converges or diverges or inconclusive. That's it, good enough to know. Yeah, in this exam, there's another question from Christian. Yes, only ratio test. Integral test and other things we taught you is amazing. It's very important. But then somehow if you check the exam review, it doesn't go to the exam. So I don't include anything, whatever is not covered in the exam review, just because kind of like good enough. Now let's practice ratio test, but with unknowns. Example 2. For example, when we have X in it, this is the one that usually asks you find the largest open interval of convergence and the radius of convergence of the series, and then we give you the series 3. That's too simple. Let's see, something from the review, but also not the trivials. Actually, it's not that. This one maybe was -1. Let's practice what happens with -1. -1 to the n, x n plus 1 all over 3. All over, I said. Yes. 3n minus 1. N is from 1 to infinity. Something like this. Can you do it on the test? So solution, we're going to use ratio test again, ratio test. This time there's x involved, but you don't even think about it at first. You do the ratio test just the same way I just did. Ratio test says find the limit as n goes to infinity. So since we put absolute value, you don't have to be bothered by -1 to the n. I would not even write it down, -1 to the n plus 1 over -1 to the n. And negative goes away. Because, okay, what goes away? -1 of absolute value is 1. It doesn't go away. It gives you 1, and that's why we don't care. But absolute value will be important for the x. X can be negative. Absolute value, make sure it's not. So x n plus 1 plus 1. Some people become so fluent or good with ratio tests, they know how to put corresponding terms above each other right away. Do you see what I did? So I just divided by the original right away. Times. Okay, 3n plus 1 minus 1. And then the original one is flipped, 3n minus 1. Does it make sense, or I made it worse by like skipping the step? I collected the terms right away, basically. See what I mean? So ask me if that was weird. Let me see if people are asking. No, nobody's saying anything. Now simplify. Limit n goes to infinity. Absolute value, keep that, that's important. X to what power? X to the n plus 2 minus n minus 1. So that's to the minus 1, right? Like so. So then 3 to what power? N minus 1 minus n gives you 3 to the minus 1, something like this. So, well, something like this actually have to be very good and important. And let's put absolute value everywhere so we don't mess up here. Then is going to be the answer. What is happening at infinity? Well, I don't even have any more n. So as I understand, that is going to be the answer. So it's going to be supposed to be x to the first. Let me see. Oh, you're right. You see, I made a mistake almost on purpose, but it wasn't on purpose. N plus 2 minus n minus 1. It should be plus 1. So the answer of the limit will be x times 3 to the minus 1. So it's over 3. No matter what n is, this is the answer. You cannot put this as the answer. They're asking you, so for what x we have the convergence. Find the open interval. So you make it less than 1. You force it to be less than 1. So that's when this problem actually have steps. Step 1, figure out the answer for the limit. It better include x unless x went to 0 in some cases of your homework. You saw that. I'll show you this example in a sec. Step 2, solve the inequality. Solve the inequality. Check out what I'm going to do. X over 3 is less than 1. I will multiply by 3 right away. Moreover, I'm multiplying by absolute value of 3, so I don't have to actually change the inequality if it's negative. X is less than 1/3. Not only this gives you the radius right away. Radius is 1/3, but it also gives you the center. Center is 0. X minus 7, blah, 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 would have different center.
Shouldn't it be 3?
Thank you. What the heck? Why did I write down 1/3? Yeah, see, that's why I don't teach after 1 p.m. Usually I'm trying to teach. Radius is 3, because if you remember, multiplying by 3 gives you 3. So, and now you can either write it down that x is between -3 and 3, or the interval x belongs to, you don't have to memorize the sign, it won't required on the test, from -3 to 3. Answer, the large, well, that's actually the answer. Answer, the largest open interval of convergence for the series is from -3 to 3. Radius is 3, center 0. So it means from -3 to 3, the series will not blow up. Moreover, it converges absolutely. -1 to 3, Let me think. No. So this notation tells you that you should have from -3 to 3. You can also, maybe if you learned in school to do like this, why not? Then you will have x over 3 is from -1 to 1. Then you multiply by 3 and the answer will be the same. It's still from -3 to 3. But the way I did is easier and actually eliminates some mistakes. And also reviews the radius right away. I like it more this way. Makes sense? Very good question. Thank you. So that is good. Now,
Or
how
shouldn't it be
about
close interval? I mean,
actually, I should not include
Yeah.
this. Yeah, thank you. Strictly less. So open. Thank you. Open interval and called strict inequalities. Very good. Example 3. Thank you. See, people pay attention. That's very nice. Example 3. How about this kind of situation? When you have n factorial, 3x plus 1 to the n is from 1 to infinity. Same thing, ratio test. It's probably going to be the last one, but we're going to do ratio test. Ratio test. Maybe I should say answer x from -3 to 3, so it converges on. That is the answer. In case it is a multiple choice question, you will see that converges on blah, blah, blah. That is correct choice. For this example, you repeat the whole process, but why I claim it's going to be different. Absolute value, n plus 1 factorial, n factorial, multiplied by 3x plus 1, n plus 1, divided by 3x plus 1. You see, I'm collecting the terms right away, over n. N goes to infinity. So let's simplify what we can and see what's going to happen. N goes to infinity. I have n plus 1 factorial and n factorial are simplified to the n plus 1. But since I think some people are still struggling with this, I'll explain. N factorial is 1 times 2 times 3 times blah, 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 times n. N plus 1 factorial is the same thing up until n, and then one more, n plus 1. Because all of these are products and they are multiplied, you can cancel them out. So the answer will be the leftover, which I like to call the tail. Now, 3x plus 1 also can be simplified, since the one at the top has larger power, that's the one gonna stay. So times 3x plus 1 to 1, absolute value. Not very clear what is happening here, so let me rewrite nicely. It's going to be a limit n plus 1 that's left over from n plus 1 factorial, and then 3x plus 1 is a leftover. N goes to infinity. What's the answer for this limit? Unlike in the previous one, in the previous one, 5n plus 8 over 5n plus 3. Find the leader at the top, find the leader at the bottom. And the leader, I mean, by saying this, n to the highest power, then the limit will be the new limit of only leaders, ratio of the leaders. If they have the same power, the answer will be the ratio of the leading coefficients. That's why we got 5 over 5. Reminding you limits from calculus 1. I also have video on this. But in this case, this goes to infinity. So the answer is infinity. What is happening here? I don't know. That's crazy. We don't even have to solve for x anymore. No matter what x you have, it goes to infinity. If x is 0.000001, you think it should be less than 1, but multiply by infinity, it gives you infinity. So no matter what x you have, this is your L, and L is greater than infinity. So be very careful how to answer, especially if it's multiple choice. Answer. Let me give you multiple choice cases to make it better for you. So answer converges for 3x plus 1 less than 1. Answer diverges. Diverges. For all x. Answer converges at the center. Answer, I don't know. And that's a joke, but I mean by this inconclusive. Inconclusive. And one more answer, none of the above. There's always the answer like this. None of the above. None of, and since they are randomized nowadays, we change to none of the others. Because sometimes none of the above now online shows up first. So there's nothing above it. None of others. None of the others, or none of the other choices. Okay, so what should we do about that? What do you think? Post in the chat. And then I'm kind of curious what you're gonna say. What do you think we should choose? Should I number them A or B or C or D or E? Which one would you choose? What do you think about that? Let me see the chat. So the chat says B, which is not correct. I have to upset
Oh,
everyone here.
None of the other?
No, so it's not A either, and it's not E, and it's not D. So there's only one left. Okay, that's why we're reviewing it, right? Very good that we're reviewing this, because you might stack this on the test if you have this question, which I cannot tell you if you do have. The correct one, it converges at the center. The thing is, let me make notes, and that will help you a lot. Note 1, power series, they do converge all the time at the center. Power series converge, they converge at their center. Let's put V, at the center, because at the center, they just give you nothing, or that one fixed number. So converges at the center, and the center is what makes 3x plus 1 0. So in this case, it's x equals minus 1/3. That is the correct answer. It converges at minus 1/3 only. Converges at the center only. And then it blows up everywhere else. Because if you plug minus 1/3 at the very original one, so this gives you a center, right? Center is x minus 1/3, like so. If you plug it at the original one, the series gives you 0 right away. So that is a finite number. Moreover, let me just write it down again. This sum n factorial 3x plus 1 to the n at x equals 1/3 gives you what? N starts from 1. Let's write down to make sure we understand that. When n is 1, it will be 1 factorial 0, right? Because it's minus 1/3. Plus n is 2, it's going to be 2 factorial 0 plus 0 plus 0 plus 0. That is not an infinity. As you can see, that can be 0 all the time. So the series does not blow up. It actually stays at the low level, 0 in this case. Then it converges there. The problem is they ask us to find note 2. Note 2. Largest open interval. Open interval. That's the thing. There's no interval anymore. There's no step away from the center minus 1/3. Not even any kind of step can be done to move away from this point and stay safe. You only save it minus 1/3. The moment it's not 0, n factorial blows it up to infinity. That's the point here. So that is why radius is 0. Radius is a step size. So radius is 0. And the open interval is not an open interval anymore. It's only a number, which is denoted by braces. That means converges at minus 1/3. So to denote one number, you use braces, minus 1/3. It converges absolutely at the center. What do you think about that? So the answer is C. Let me circle it. The answer is C. Is it weird? So there is always a convergence part at the right away. And then we ask, that's why we're asking you, find the open. If you see the homework, it actually says, what is the open interval? So they never actually tell you, find if it diverges, because it always converges at -1/3. What do you want to say? Any questions or comments? So power series, oh, they converge to the center.
How come it doesn't go to infinity?
So it's 0. So it gives you 0. 1 times 0 is 0. 2 factorial times 0 is 0. 3 factorial times 0 is 0. 4 factorial times 0 is 0. So it gives you 0. Even a million factorial is a huge number, but times 0 is 0. That's why.
So could it be said that it diverges for all x values except the center in this case?
Exactly. Let me say that. That is a good way to explain it to you.
Wait a minute, does it give a point that it's at, or is it just the limit?
It is, so it gives you a point. Very good question. The point is 0. So that is not the limit. It's literally all infinite sums still 0. So it gives you 0. And remember, definition of convergence for the series, it should give you a finite number, and it does. This is area between the graph. That's one of the ways also to explain it. All those dots are sequences, area below. Do they blow up? Well, they shrink to 0. Actually, from the beginning, they do not even grow. It's always 0. That is why it converges at the center. Let me write down this note. Actually, it's a good way to say it. Diverges everywhere, diverges everywhere. Oh, I did it. Everywhere. Except, oh, don't ask me to write down except, right? I see there should be a somewhere, except. X equals center -1/3, except the center. That is what I'm talking about. Is it correct to say except like this? Except. Let me write it. Yeah, looks good. No, it should be E. See, nobody said anything. Good. That is one of the things also to mention. So for everything else, you have to solve for X. For all others. Moving on. That's
What
ratio
if the
10.
series didn't have the 3x plus 1 factor?
Oh,
Would
very
it
good
just
question. Then
end
the answer
on-
diverges.
Okay.
Yes, very good question. Very good question. There was example like this in the review as well. This one. Oh, you see, that's a very smart that you asked that. So let me find this example. I remember it was there on the review. Which is, then if there's no X, then it converges everywhere. Then it diverges everywhere. I guess this was this one. And factorial. Let's practice more factorials. I'll just made it up. One more example without X, so you can see the difference. X messed everything up. That's the point. That's why it's called infinite polynomials. But that was example number 2. And example number 3. Now example number 4. Example 4. What if the series looks like this? N plus 3 factorial over -5 to the n. And there's no, as you can see, and there's no X in it. Let's see what's happening here. Limit. N goes to infinity. N plus 4 plus 1 plus 3 factorial divided by n plus 3 factorial. Do you see how I'm kind of speeding up the process? Don't forget parentheses. That's important. divided by -5 to the n plus 1, but multiplied by -5 to the n absolute value. Do you see what I mean? Like, that's how fast I usually start doing it at some point. As a student, I realized, okay, if we collect the terms, why not collect them right away? Unless I mess up, then it's fine. But then, so the -1 should not be even bothered because the absolute value makes out of -5, it gives you 5. So I will have limit, simplify, n goes to infinity. N plus 4 stays, that's it. So from these two, now the tail going to stay, and the tail is n plus 4, whatever is not the same between those two factorials, that's n plus 4. And then from -5 situation, I will have 1/5, that's it. Absolute value, because -5 to the n time, or I would say n minus 1 gives you -1. And then minus got killed, eliminated by 5. When n goes to infinity, that gives you infinity. So thus, since there's no x involved, the answer follows. Answer. No. Diverges everywhere. Diverges everywhere. That is, well, actually just diverges. There's no interval. So I guess that's the way I should say it. For the series that involve x, the sum a to the n, x minus c to the n, that's how we call it. N is from 0 to infinity. That one have a convergence set. Convergence set. And that's why we keep convergence set. And that's why I keep asking you to find the convergence set. And that is either a one number. Remember we had a table I showed you. It may be just one number, which is a center, center C. Then radius is 0. Or it's an interval from, say, m to n. Then there's some kind of radius. Or it converges everywhere from -infinity to infinity. We had cases like this too. Then r is infinity. But if there is no x involved, then there's no choice. If this sum is just a sub n, c to the n, what did we call it at the very beginning? To be consistent, I would say a sub n, that's it actually. So if it's just a sub n or c to the n, whatever, n goes to from 0 to infinity, then this one, you just use the ratio test to find out. Ratio test gives you L less than 1, greater than 1, n equals to 1. That's how my review started also. I did it without x, and then I involved x. So that is the difference. Either you have a final answer, infinity is greater than 1, so the answer follows. Or you use this knowledge of the ratio test to find the interval. Solve for the absolute value less than 1. That's what we do.
I just had a quick question.
Yes.
So going back to the previous problem, how did you get 0 from 3x plus 1?
The 3x plus 1. Oh, I solved it. So this, yeah, good question. This equals to 0. Center is where, that's why it's called the center, is where the definition of center is this. Let me tell you. This way I think it's better to explain. From the formula, C is a center. So as you can see from the formula, C makes the whole series 0. That's why it converges there all the time. Because x minus c will give you c minus c will give you 0. That's what's happening here. So knowing this, I needed to find where it gives me 0 for 3x plus 1. 3x plus 1 is 0. 3x is minus 1. X is minus 1/3. Solved for that. Yeah, that's kind of the way I would explain it.
I see how you got that. That makes sense now.
Thank you for asking. Did I make a mistake? People keep saying something, no? I think, figure out. N plus 4, yes, I added 1. N plus 1 plus 1. n plus 1 plus 3 became n plus 4. I just speed up the process. Yeah. You don't have to do it if you're not feeling comfortable doing that. Especially people who are not very tedious with small things. You better write down everything then. Very good. What's next on the menu? So we did this, we did that, 3, blah, blah, blah. Building the Taylor series. We did that on Friday. So it's fine. Let's just review everything. It sounds like, why not? So we're gonna do several things. What we reviewed is how to play with functions and create new series out of old series, and then how to build a new series from scratch. Let me check on the test. Basically, I'm looking at the test right now. Ratios test, ratio test, ratio test. Either claim the result or find the most open interval. So that's it. Now the building series starts situation. Let's build later. And for now, just do this. We're going to do what's Taylor-McLaurin series, right? It was chapter 8.5. I think they call it series as functions or functions as power series. Yes. Functions as power series. Power series. And then we're going to, after this, jump into Taylor and Maclaurin series. So we're going to do this right away. Let's do the first one. The first one, we just started with geometric series. Geometric series was the main guy for quite a while of your homework. Geometric series says we used to have a formula which was like so: a r to the n. N is from 0 to infinity. This thing converges for absolute value of r less than 1, and we even know to what? To, and that's what I'm going to put at the equal sign, s to s. And the s had the formula. First term, let's call it a, 1 minus common ratio. That was the formula. A over 1 minus r. Converges only when this common ratio is less than 1. So that's what we called capital S, converges to that. But then what we did, we said, let's A be 1 and R be X. And this is where the series showed up. The series became, 1 over 1 minus X, right? Equals. So A is 1, R is X. As sum, A is 1, so just 1 times X to the n. That's where this formula came from. We just renamed a couple of things in the power series, in geometric power series, in geometric series, and created a power series out of it. That's where this thing came from. And then you can see that x's have to be less than 1. It only works for x by absolute value be less than 1. It came from geometric series. So that's geometric series. So now it's geometric power series now, but people still call it geometric series. Nobody cares to put power in it, but okay. Geometric power series. That's the only new thing here. Where did the sign came from? Okay. Okay, there's a whole conversation going on about something else. So I will join that conversation in a second. No idea what's going on over there, but it's okay. So it happened when I was teaching online through Zoom. People would get distracted, and then I would jump into conversation and something completely random. And I was kind of okay with that because it was fun. So the only rule was to have appropriate, no inappropriate conversations. Now, examples. What was the whole point of this? We will ask you to build some kind of weird functions out of this knowledge. For example, from the review you saw, we had 5x cubed over 1 plus x to the 7. Oh, that's pretty cool. So that's what I gave you on the quiz, right? You're like, yeah, I can do that. Can you find the series for this? You have 2 ways of doing it. 2 ways of doing it. The way 1 is to build it from scratch. The way 2 is to use known series. Let me give you the table So on the exam, I don't plan to give you a table because it will distract you. Instead, I actually said, use this for number 5 or use this for number 11. Because last 1 year I gave a table, students thought it would be better. And then they got so confused, they start putting them everywhere. So it actually made it worse. So what I did, I just said, use this. That's it. So this is actually much better than having a table. I think it's better. Then, so way one, build from scratch, build from scratch. And that's what I did on Friday. And now I have a video recording if you want that. Way 2, use known series, which called McLauren series. So let's use this one as we know the geometric series. That's the one. Solution. Whatever is faster, I don't want to deal with quotient rules. It's annoying, but you will know that the answer will be the same. That's the whole point of this knowledge. Solution, use 1 over 1 minus x equals sum x to the n. And you know how I teach it. I read it like this. 1 over 1 minus input equals sum of input to the n. So we will have 5x cubed kicked out, 1 over 1 plus x to the 7. Looks better than before, but I need minus. So you know the trick. It's going to be 5x cubed, 1 over 1 minus. And the new input now shows up. Minus x to the 7 is my new input. So following the formula in blue, here it is. It's going to be 5x to the cube is keep waiting. This sum shows up. And the formula says input to the n. My new input is minus x to the 7 to the n. This only happens for x and less than 1, for the input less than 1. So my series only happens for minus x to the 7 to be less than 1. That is also important to mention. This is the answer, but you will not see it as a multiple choice question. And also on the exam, we told you, no, I want you to have sum standing by itself and then everything inside. So we have to simplify. And also for the series, you will see I simplified it for you. So now you have to figure out. Go figure. That's what they say in English. 5x cubed went inside of the sum, like so. It's a product, so we can just distribute it. Minus 1 to the n times x to the 7 plus n, or 7 times n. That's important not to make this mistake. Which one is correct? Who's paying
7n.
attention? Times n. Thank you. So times n. Make sure you remember that x times x to the a times x to the b gives you xa plus b. But x to the a raised to the b gives you x a times b. Very quick. See, 5 seconds, and I remind you. So minus 1 got kicked out from here. That's important. That indicates we are working with alternating series. Sum 5 is 5. Don't touch 5. X 3 plus 7n. See the formula I just showed you. Times minus 1 usually goes to the very front. That's actually not smart to keep it at the end. Minus 1 is indicating that it is alternating series. So I put it in front. That's class quotation internationally approved. That's it. Can you find this in the list? Can you find this in the list? Someone should be muted. Who is that? Amar, I found you. Mute. Nice. Can you do that on a test? So that's what we want to do. Use a known series to create a new one. And then we introduce the table of other functions. So sine, cosine, e to the x, blah, blah, blah. Alternating negative, yes, let me write it down. Thank you for pointing this out. Minus 1 to the n gives you the understanding that this is alternating series, which means it changes a sign. It might start with minus 1 or not, but it changes the sign. So either it's plus, minus, plus, minus, plus, minus forever, or minus, plus. So that's we usually don't write this down because it's going to confuse people even more. So like so. And it goes forever. Alternating means changing, alternations. So that's what we wanted to do. And I will give you the formula, so don't worry about that. Then How about the McLauren series? What if I will ask you to find, using the same method, something like so. So there was example, that was example 1. Example 2, from the geometric series chapter, we moved to McLauren series, and that gave us a whole list of awkward functions. For example, how about something freaky? Which is like sine and cosine, right? Let's do that. Those have like quite long formulas. For example, find the series for what should I just make up something fun? Like, for example, x over 7 and x is raised to the 17, because why not? Times sine, and sine is not of x. Sine is x over 3. Yes, yes, this will be good. This will be like very confusing. So let's do that. Find the sum for this. Sum, question mark. That's what we're asking you to find. Solution. Solution, and the formula is use a known formula, and the known formula is sine x equals this sum minus 1 to the n x to the 2n plus 1 over 2n plus 1. Some of you wrote those formulas not correctly and stuck in your homework. That was interesting. But luckily for the test, I already typed it in for you. It's already typed, so you're safe. Right? Yes, I see it in the test. It's typed. This is an odd function, which makes sense. Sine is an odd function, and it's alternating, which makes sense because sine can be negative and positive. Solution, we're going to have x 17 over 7 times, you right away, no need to do anything. Use x over 3 as a new input. Plug it everywhere, copy and paste, everywhere you see x. So it's going to be minus 1 to the n. New input is x over 3 raised to the 2n plus 1 over 2n plus 1 factorial. And I lost the sum from 0 to infinity. Does it make sense? That is a series. The series showed up from the sign. Copy paste everywhere you see x. Put x over 3 instead. Where did you get 17? 17 was there. I just made it up. I created. I'm the god of this review. Okay, I created 17. So it's there. Here it is. Here is 17. Okay, good. So next move is if you're putting this inside, right? Because you can, why not? Sum, then you have x. Well, keep the minus 1 outside. Don't touch it. It's already there. Why bother? Put it there. Times now x to the 17 over 7 times. And now the simplification happens. This is when you should not make a mistake. Try your best not to make a mistake. X is raised to 2n plus 1. And 3 is raised to the 2n plus 1. That is very important. If you did not put those parentheses correctly, you messed up. If you put parentheses only on top of x, you have wrong answer. And so on. So basically, it's all on you to be very tedious with powers. Algebra, baby. So that is not the end. You also have division by 2n plus 1 factorial. Good. We're going to collect the terms. Sum minus 1 to the n. X is collecting together all the powers. 17 was there originally, plus 2n plus 1, not times. Remember the formula I just reviewed. Over 7 is in denominator. 3 is denominator. 3 is raised to the 2n plus 1. And there's a 2n plus 1 factorial. That is the answer. That is the answer. Can you detect this amazing, beautiful series? from the list if it's a multiple choice question. N is from 0 to infinity. How about that? How about that? What do you think? Questions about that? I will have my team. Okay, it's great. You see? Chris is like, it's great. Did you see
In
my
the
small
exam,
cup of tea?
like, will we have an additional question to like questions like this? Like, will we need to find something else, or is it just a sum?
So what else can be done? Just this, whatever I just did. This is a very good question for the test. Is that what your question was? So this is on a test. Either sine, cosine, e to the x, log, and I give you the formula. That's what I mean.
Okay, got it.
So someone says, hope it's not complicated. That's the thing. What I think is complicated. It's not the same thing what you think is complicated. It's actually every time I create exams and I'm trying to put simple stuff and then people stuff. So for example, that's a problem. You cannot read students' minds to know where students will stuck. I thought some kind of hardcore stuff will be hard. Everyone did amazing last semester on that, but everyone messed up algebra. And then I switched that and then it became better. So it's you never know actually where students mess up. It's very interesting to see as a data, each generation is a bit different, but most of the time people, it's hard to guess. For example, I thought this question is the easiest question in the world. This one, I gave it to you on a quiz and everyone stuck with it. That's just interesting. I did not expect that at all. The question in the quiz was number 3. It asked you, what series you should integrate? You should integrate or differentiate, integrate or differentiate to get, and then I gave you arctangent. This question takes arctangent not of x, arctangent of x squared over 3. This question takes half minute to answer, but everyone's stuck with it. That's the thing. That's why you never know where students are actually stuck with it. And I saw that people stuck in both places. Answer. First, you think what function, not the series. So you first kind of forget about the series for a second. You ask yourself what function you should integrate to get arctangent in general. Well, integral of 1 over 1 plus x squared dx is arctangent. Oh, why not just keep x? Then I think I gave you x squared. X. Did I give you x or x squared? I already forgot, to be honest. Which one was? And I want to be consistent. I think it was just x. Arctangent, yeah, it was just x, nothing extra. Sometimes we give extra. Arctangent x plus c. You remember that. This is just that, right? This is from calculus 1. Then they ask you, but we don't ask about the function, we ask for series. So they ask you, so what is the series then of this? No, of this function inside of the integral, because that's what the question is asking. What series you should integrate or differentiate to get arctangent? I know how to get arctangent. We're integrating 1 over 1 plus x squared. Thus, or so, therefore, the answer is 1 over 1 plus x squared equals this sum, but we know geometric series. Table number green.
Outside, it's crazy.
Jenny,
One
you want to slide?
over 1 over, Megan got unmuted. Huh? Okay, good. 1 over 1 minus input gives you input to the n. So I know the answer, minus x squared to the n. That is the answer. Does it make sense? So it's, if you want to rewrite it, minus 1 to the n, x to n. We're integrating this series to get arctangent. What do you think about that? The solution is to give everyone 100% on the exam. If you do well, I don't mind. If you do well on the exam, I can give you 100% on the exam. That's a good solution. So, Christian, have a question.
So when it comes to functions like arc10, are we basing it off of identities we've seen beforehand, or?
Yeah, exactly. We basically use it as we've seen before.
Okay.
Exactly. That's a
Thank
good
you.
question. I also have more examples. Let me ask you guys about this one. If you put the expanded version of that for the quiz, is it still correct? If the expanded version is correct, that is correct. If you put this at 0, it is 1. So no sum anymore. At 0, it is 1. At 1, it is minus x. At 2, it is plus x. Oh, x squared. To the 4. At 3, it is x to the 6. If you put that, that is correct. So if the expansion is correct, then it is correct. But I prefer the one in the box because that's what I put in the multiple choice question everywhere. I did not give you any extensions. All of them are sums. So one more example actually is this one. Same question. Same question. What do you need to differentiate or integrate to get? Is it to get? To get 1 over, no, wait. To get ln 1 plus x. How about that? How do you get ln 1 plus x? Same thing. Solution. We know that integral of 1 over 1 plus x dx is ln 1 plus x plus c. Don't forget actually plus c, right? So they ask you to find the series for this. And this series for 1 over 1 plus x is sum minus x to the n, which is sum minus 1 to the n, x to the n. That's what they say. Find this series. Finally, the question is you have on the practice exam. The practice exam asks you questions like these. What did you integrate or differentiate? What series did you integrate or differentiate to get arctangent? And you will say, well, I'm integrating the series for 1 over 1 plus x squared. How did you get ln 1 plus x? Well, I'm integrating the series for 1 over 1 plus x. Make sense? That's what the idea is.
How did we get minus x whole to the power n?
Yeah, that's a good question. Thank you. The formula is 1 over 1 minus x. That's a geometric series. So the moment I see it doesn't match, I have to fix whatever is not matching. So that's a geometric series. 1 over, so let's say because BC, 1 over 1 plus x can be written as 1 over 1 minus x. The new input is now minus x. So the series becomes minus x to the n, and then n drops onto each minus 1 and x. Make sense? Yeah, good job. That's a good question. So that is all you need to know until we start building the functions, right? Because that's what the questions on the practice exam, you see it on the review, that's nice. And now we build we build them from scratch. That's what we did on the quiz. X to the minus 9, x to the minus 3, whatever, sine x plus 7, blah, blah, blah. So let's review that, building from scratch. We're talking about Taylor series. Taylor series. Maybe start writing the formula all the time. It might help you if you see it. If you start writing the formula is any infinitely differentiable function can be written as a Taylor series, which is a sum, coefficients, and then x minus center to the n. N is from 0 to infinity. And the most interesting part is how to find those coefficients. Coefficients are, they were found from the theorem, and we did it in class actually together. Coefficients are found like so. Take n's derivatives, plug the center, divide by the n factorial, that is c to the n, multiplied by x minus center to the n. N is from 0 to infinity. And let's rewrite it term by term. How do you get that? Since n is 0, see what's going to happen. When n is 0, it's going to be f zero derivative. Zero derivative, that's the original function. So first original function at a divided by 0 factorial multiplied by x minus a to the 0. Next one, when n is 1, you will have first derivative at the center a divided by 1 factorial x minus a to the 1 plus when n is 2, you have second derivative. You can write down prime if you want at the center divided by 2 factorial x minus a squared, and it is keep going. So that's how this formula is written, and it's keep going. See, it's a power series. It's an infinite power series, converges at a, and in general, then we may actually claim there's a theorem converges everywhere. That is the formula. We're not going to give you this in the test. That is very important. Everyone know it around the world. Whoever takes STEM classes, we teach them those things. So that's extremely important. Exclamation mark, smiley face. That is very important. So let's start building things. What if I tell you that sometimes we give you stuff and you don't have to build it from scratch? So we're going to practice, of course, building from scratch. But what if you don't have to? So let me practice that just a second, just for a second. For example, example 1. Find a Taylor series for the function f of x if we know that f original at 3 is 17, the first derivative at 3 is 21, the second derivative at 3 is 0, the third derivative at 3 is minus 10, and the fourth, see, the 4 becomes in parentheses already. We don't do prime. At 3 is 0, and the fifth derivative at 3 is 0.12. That is a data collection. So that's very interesting. At some point, you have devices and they recorded position, that's f of 3, at 3 seconds, for example, of the molecular. Then it's the velocity, that's the first derivative, then acceleration, then jump. I think that's like a pop. I think some kind of fifth derivative is pop, I think, whatever. So physics. Or at some point, some kind of derivative represents density, whatever. I don't remember. That's physics major people, they know that. So what if you have that? Can you create now a function? Can you create now find, so let's define Taylor series for this function. Find Taylor series at the center 3. So people ask me, is it A3 or X3? That's the same thing. They say at X equals 3, that's the center. That's the center. They sometimes call it X sub 0 or A or C. That's people do not agree on that, how to call, unfortunately. For f of x, which means they want you to find f of x equals some blah, 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 or written down just like terms. Solution. We know the formula. Maybe write it down again. F of x is the first, so original function at 3 divided by 0 factorial, x minus 3 to the 0. 3 is a center, so you have a shift. The moment you have not 0 center, that represents a shift. That's a Taylor series. If you have center 0, that's Maclaurin series. Plus f first derivative at 3 divided by 1 factorial. I would skip writing all of this. 1 factorial, blah, 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 at 1. But I wanted to have good notes for you. Plus, write down by yourself what's happening after this. While I'm moving it around. Nice. Plus f prime prime at 3 divided by 2 factorial x minus 3 squared plus f prime 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 at 3 divided by 3 factorial x minus 3 cubed. We have 2 more, right? So plus, keep going. F prime 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 prime, that's done. So people do 4. 4 in parentheses, that's international notation, divided by 4 factorial x minus 3 to the 4 plus f to the 5 over 5 factorial x minus 3 to the 5 and keep going. But we only know these. So if you cut it off, you call it Taylor polynomial. Find a Taylor polynomial if there's a cutoff. And we're cutting off on the data we only have in front of us. Let's do it. F of x is, whoever was sleepy just woke up or went to death from yelling. We are given these derivatives in yellow. So my job is to know the formula and divide them by the corresponding factorial and multiply them by the corresponding x minus 3 to the power. So that's what we are doing here. Do you understand now? And because I'm smart, I'm going to skip the zeros. So the moment I see 0, that guy will be skipped. But I also write down to have good notes. But 0 means that term is missing. So I wanted to ask the question. 17 is f of 3. And I will not divide by 0 factorial because it's 1. And I will not multiply by x minus 3 because it's 1. So it's 17. 17 and 17. F prime at 3 is 21. 21 multiplied by x minus 3 to the 1. Where did you go? Oh, let's see. The charger is dying. That's fine. Should last. Nice. Now, let me prepare the charger. You have f of 3 is 0. So 0 plus, and not f of 3, f prime prime at 3 is 0. F prime 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 is minus 10. So let's not put it twice. Minus 10 divided by now 3 factorial x minus 3 cubed. And you see, I don't put 6. Actually, people keep the pattern nicely. 0 was divided by 2 factorial, if you're curious. Plus 0, fourth derivative is 0, plus 0.12 divided by, I don't remember, x minus 3, I don't remember. That's when you have to be careful. 3, 4 was skipped, 5 divided by 5 factorial to the 5. Do you see what just happened? So can you choose this from multiple choice question if it's on a test? And you can see it in the exam, practice exam as well, and in the review. What do you think about that? So that's supposed to be an easy question if you know what is happening. But you see, I'm not claiming it is because I don't know. It's hard to know what different students have different understanding of the material. So it may be easy, maybe not. What do you think? So you see, if we have, like sometimes people say given the data, this data was collected, given, like so. Find the Taylor series for f of x without knowing what f of x is. We just know f of 3 and find in derivatives, and not even all of them, just some of them. And that wasn't good enough. And that's why they have lots of applications. Like imagine this is specifically meteor flying or whatever in the space, or a planet with, and then you detected velocity, speed, acceleration, distance, and other qualities of it, how hot it is, if it's radioactive. From these, you can build Taylor series. Now you can find it maximum, minimum, optimization problems, and many more. Differentiate, integrate, blah, blah, blah. Does it make sense? What do you think of that? Let me see the chat. What sort of questions would we get for the free response? Oh, yeah, I cannot tell you that. because we keep changing them between semester and semester. So you kind of need to know everything. Usually whatever worth writing. So whatever can have the answer in 5 seconds is not worth 14 points. We only have 2 multiple choice questions in this class this semester. Usually we used to have 3. So for 14 points, I cannot put something that's worth like 5 seconds. But in this chapter, everything takes time. Did you notice that? Except 9.1 and 9.2. Some of those questions are like one-step question. These obviously not going to go to free response. And I can show you in a second what is it. But these all take some steps. So all of them, to be honest, might end up to be on a free response. Let's practice. So practice number 23, 24, 25, all of these, exactly what I just showed. Series with the given derivatives. Let's practice one building from scratch, which we did on the quiz. So, but I can practice any other if you want. Yeah, most questions are lengthy. That's because it's a power series, at least except the beginning of the chapter, everything takes time. So let's practice quickly. I can see in front of me, find the series for x to the minus 3. F equals. So what series it will have, right? We don't see it in a table, even though actually there is one in the table, but okay. We don't see it in a table, so let's build it from scratch. I can even do it. Very interesting, actually. Do you know? Like I can put some kind of like x minus 3 plus 17, for example. How about that? So I will change it a little bit. How about that? Can you do the sum for that? So that build from scratch solution. Way 1 builds from scratch. Way 2 use known series. I don't see known series, so we're gonna build from scratch. Let's build Taylor series at, and they give you at what? At a equals 1. Oh no, it's not 0. So now it will require some calculations. At a equals 1. That's a center. That center checks your knowledge of the shift. That means the formula will require x minus 1 to the n situation. Don't forget that. Not only we're plugging 1 everywhere, but we're also having a shift. So again, let's write down the formula before building it. The formula will be f of x will be original function at 1 divided by 0 factorial multiplied by x minus 1 to the 0 plus first derivative at 1 divided by 1 factorial multiplied by x minus 1 to the 1 plus f second derivative at 1 multiplied by x minus 1 squared divided by 2 factorial plus f 3 derivatives at 1 divided by 3 factorial x minus 1 cube, and let's keep going. Do you understand that? So this is the first step, which is kind of the most important and I would say hard, is to remember this amazing formula. So if you can do that, that would be amazing. I would really hope you can do that. Maybe, you know, when the exam starts and you have a scratch paper, just write down the general formula in front of you. So now you can see it. That's not cheating. If you write it down from your own brain, that's amazing. So that would be nice. Just write down all the formulas right away. I will try to go over number 41 from the review at the end. Yes. So now we have that. Let's start building it. So first we need the original function at 1, this one. So students can write down right away. But I like to write down f is x minus 3 plus 17. So f at 1 will be 1 plus 17, which is 18. So that will be multiplied by x minus 1 to the 0 divided by 0 factorial, like so. But if we just ask you for the coefficients, then you should not include any x. Coefficients don't have x in it. So it's divided by 0 factorial and multiplied by x minus 1 to the 0. That is what's going on here. Now the first derivative is minus 3 goes down to the minus 4. Who is keep integrating instead of differentiating? I saw several people doing that. Stop integrating when we need to differentiate. Minus 3 goes down to the minus 4. Plug 1 into this madness. It's going to be minus 3. Then it will be divided by minus 3 is divided by 1 over 1 factorial and multiplied by x minus 1 to the 1. F prime prime will be just F prime prime will be minus 3 times minus 4 is 12, x to minus 5. Plug 1 into second derivative. You get 12 becomes and multiplied by 1 over 2 factorial and multiplied by x minus 1 squared. Third one, 1, 2, 3, minus 70. That's it, right? 5 times 2, 60. Minus 60, x to the minus 6. F 333 at 1 is minus 60. So divided by 3 factorial. You can ask me how far we're gonna go. I will tell you on the homework and on the exam. We tell you how many terms we want. All of this is infinite, of course. Let's keep going forever. But I will tell you either to which power to get or how many terms we want. So for example, this is good enough. The answer follows right now. The answer will be these things multiplied in n, multiplied in n, multiplied in n. Because that's what the formula says. Check this out. The formula says find the derivative, plug the number, divided by the corresponding factorial, multiplied by x minus shift, raised to the corresponding power. That's exactly what we're doing here. So the first term is f of 18, f of x equals x to the minus 3 plus 17. And that function has its own Taylor series at the center one, which is, the first term is 18. That's it. The second term is minus 3 multiplied by x minus 1 to the 1. The third term is plus 12 divided by 2 factorial, which is 2, x minus 1 squared. And one more term we found was minus 6 divided by 3 factorial, which is 6, multiplied by x minus 1 cubed plus, and keep going. This is an alternating series. Taylor series for the function. What do you think about that? Can you do it for the test? Can you do it for, this is what the quiz problem was. What do you think about that? That's called Taylor polynomial if we just stopped at x cubed, by the way. So, yes. I can hear you. If not, we're moving on completely away from Taylor series. We're done. That's all serious stuff I need you to know for the test. After this, we're going to on chapter 9, which is parametric and polar. Well, no polar for this exam. Polar going to the final. What do you think about that? Can you do that? See, like if any of whatever I just mentioned is still complicated for you, that's like exclamation mark. Exam is coming. You have time to prepare. In the morning, maybe wake up early. That's my style, though. You don't have to follow it. I wake up early before the test and I just study. I come to school first to make sure I'm there, I'm on time. And then I find the empty place and I just study all of this right before the exam. My brain saw this, my brain is active. And then I sit on the test and, you know, I don't put any tricky questions on the test. I copy them from the review, whatever I mentioned, nothing tricky. It's not easy, but at least it's not tricky. That's my point. And then you see it, you feel happy, you know that I did what I said and you can do it. If it's good, you know, just practice a little bit more to avoid algebra mistakes. Okay, no questions. Oh, there's a raised hand. Yes, sure, that's the question.
All right, just to double check. So when it comes to McLauren series, the main function would be f to the n of x over n factorial, and then x minus whatever a. Maclaurin is just, we're getting rid of the a, replacing it with the 0. So the only thing we need to worry about is the x to whatever power and then the coefficient. Yes,
exactly. Very good question. Thank you for asking. So McLaurin series has a equals 0. Thus, the formula is easier. It's just not a new formula. I don't like when people try to memorize several formulas. It's the same thing, but it will be n's derivative at 0, still divided by n factorial, and then x to the n, because x minus 0 to the n. Yeah, thank you for asking. It's a very good. Exactly. So this shift we have is only for Taylor. So Taylor formula is harder, but that's why it has multiplications. It has a shift for any number. And then at 0, that's Taylor's situation. Then we don't have to bother with the shift. Very good. So do you know in my language, we say Taylor in Maclaurin, completely different in English. So you have to really learn to say Taylor in Maclaurin. Taylor, we say Taylor in Maclaurin. Fine. Chapter 9, we just started chapter 9, so we don't know really lots of stuff. So what do we need for the test? Let's just be smart and only practice things for the test. We need to know that sine squared theta, I wanted to point out why theta, cosine squared theta equals 1. I wanted to make sure that it's not just x. For you to understand examples, sine squared x cubed over 8 plus cosine squared x cubed over 8 is still 1. So it doesn't matter what's the input until the inputs are the same. That's my point. That's why we call it theta. In the future, we call theta to go to angles instead of just inputs. So just make sure the inputs are the same. That's why this property is amazing. It works for many things. Now, what do we, yes? Did you just
Sorry,
accidentally swear to my recorded video? It goes to the history from now on. So, we need to know several formulas. What is dy over dx? Well, it's derivative, change of y with respect to t, change of x with respect to t. That's what we need. What is happening? Where did the t come from? Well, the whole point of this new chapter, that's R, not P. So in Russian language, this is R. That's why sometimes I write this as R. Your P is my R. That's how complicated it is to learn English if you have different alphabet, contradicting your alphabet. So that's why sometimes I forget to put R thingy. Why the T showed up? Because X now is a function of T and Y now is a function of T. And the T is called the parameter. That's why it's called parametric equation. Parameter. Do you know how to say parameter in Russian? Parameter. It's very different. And the other formula for the test we need to know is L, arc length, so length of the curve. The gigantic, not the gigantic, but the gigantic is funny to say, so I like it more. Gigantic square root, derivative squared plus derivative squared. That's what we're doing, dt. That's all for now, what we need for the test for the chapter 9. One more thing is how to jump between, and it's more the skill rather than remembering something. But one of the skills is to know the formula for the circle, which we know from pre-calculus class. It's not new material. X minus a center squared plus y minus a center squared gives you r squared. That is a circle. Circle centered at x sub 0, y sub 0, radius r. Center in Russian is krug. Krug. Sounds like Greg. Krug. Radius r. Like so. That is important formula, which will be on a test. I don't give it to you, so you have to know that. Nice. Let's practice. What do we want here? What do we want? So we taught you several things. How to jump between different forms. From parametric to Cartesian, which sometimes called rectangular, and back, how to jump between. So introduce a parameter or get rid of the parameter. On a test, I'm mostly gonna give you, I think, get rid of the parameter. Get rid of the parameter is like so. I gave you parametric form. You need to get rid of it. 5 cosine 3t. Y equals 3 sine 3t. Jump to the Cartesian. So this is Cartesian question mark. This formula, it's a function. It's given in a parametric form. It's some kind of curve. It's some kind of picture. Maybe it's infinity sign. Maybe it's a circle. Maybe it's a parabola. Maybe it's a line. Maybe it's, I don't know, smiley emoji. So, oh, I will show you actually some cool, funny stuff next week after the test. Smiley emojis will be included as well. So how to jump to Cartesian? Goal is to get rid of t, the parameter t, whatever the parameter is. Sometimes you thought theta. So get rid of the parameter. Solution. For the questions like this, I want to have cosine square plus sine square because then it gives you 1. So let's do it. You can square each and add them together. But first, I would like to isolate cosine and sine. So then it will be easier to deal with. So let's isolate cosine sine x over 5. So I'm dividing by 5 and dividing by 3. Corresponding equations. X over 5 is cosine 3t. Y over 3 is sine 3t. Like so. Now I'm going to square each side and add, because I want to have sine square plus cosine square, which gives you 1. So left-hand side is squared and right-hand side is squared, right? Left-hand side is squared and the right-hand side is squared. And I'm adding left-hand sides being squared and right-hand sides being squared. Thus, it will be x over 5 squared plus y over 3 squared. Make sure square is everywhere in parentheses. Use parentheses, don't forget. Cosine square plus sine square gives you 1, and this is the answer. That is an ellipse. Apparently, you don't say ellipse. You're supposed to say ellipse. I did not know that. It took me forever to learn this, such a simple fact. Ellipse. So it's like so, ellipse. And it has 2 radii, 5 and 3. What do you think about that? Can you do that on the test? Did you practice that? It's in the practice exam too. Did you practice that? So get rid of the parameter. Yeah. Isolate the trick. That's like the most important step, to be honest. The first step helps you a lot. Isolate the trigonometric function. Isolate your tricks. Isolate. So hint. Yeah, hint. Isolate the tricks. Then you square both sides and add together. Isolate means let it be by itself with the equal sign. So equal sine and cosine standing by itself with the equal sign. Then it works really well. Did you get this part? So in your homework, you practice it a lot in 9.1, 9.2. Even if the numbers were added to x, like at some homework, it was something like x minus 7 equals 5 cosine 3. Still, you just isolate cosine. So it's the same idea, it still works. So this ellipse is centered at 0, 0. But if the numbers were added to or subtracted to x and y, then the center will be shifted. Do you understand what I'm talking about? It's like example 2. It's in your review. Example 2 is something like x equals 7 plus cosine. Let's just put t. And y equals 5 plus sine t. How about that? Same thing. Isolate cosine and sine. X minus 7 equals y minus 5 equals cosine t sine t. The answer follows right away from here. Square each side, add together x minus 7 squared plus y minus 5 squared equals to 1, because cosine squared plus sine squared gives you 1. That is the center. What center? Circle. It's centered at, not 0, 0. That's what I want to say. It's a circle centered at 7, 5, radius 1. Does that make sense? What do you think about that? What do you think about that? Do you know that if I multiply by 6 in front as an example, then the answer will be 6 and the radius becomes 6. Do you know that? So whatever is inside of cosine and sine actually disappears. But whatever is multiplied gives you the radius. Whatever is added or subtracted gives you the center. That comes from the formula. This formula, I just reminded you, this comes from here. Formula of the circle, centered, blah, blah, blah. Whatever is added or subtracted, that's a center. Whatever stays on the right-hand side by itself, that's the radius. So if I multiply by 6, the radius will be 6. Is awesome? How fun is that?
Wait, how do you get
Question?
6?
I just multiply by 6 random. Oh, you mean here? I just like decided to change the example.
Oh, okay.
Yeah, thank you, first. If you just to have it over there, yeah, I actually thought this was the original function. No, very original. In the original, if I multiply by 6 in both sides, that 6 changes the radius. So next week, we're gonna build different cases. This was a circle centered at 7 and 5, original radius 1. So what I did as an engineer or physicist, I said this circle is too small to show the signal or to show the water drop frequency and stuff. I want a bigger circle. How to do it mathematically? I multiplied sine and cosine by 6. That increased the radius to 6. That's kind of the applications of this idea. And I have thousands of applications, the planets and so on. So I multiplied by 6 the trig function each. And that increased the radius, even though the center is still the same. That sounds very cool. This is what kind of is interesting. So that's important. So from here, can you answer the question then? Which is question number 3. Write down or find the parametric equation, find a parametric form for, and then I give you the shape. For example, circle, where should circle go? Circle centered at 10, minus 5, radius 11. How about that? Can you figure out the equation for that? Especially if it's multiple choice, and I give you like thousands of options, like 5 pages of options. Can you figure out what we're asking you? Well, there's a formula, x. Well, that's the formula actually. You still can actually go from that formula, I just realized. But basically, the formula is x is minus center equals radius r cosine t. Y is minus center equals radius sine t. Cosine goes first, but don't worry, we're not going to actually bother you for this test. The most important about the order cosine and sine, the most important part is to know where is radius and where is the center. So if I give you different numbers, do you know which one is correct? The correct one is x minus 10 and y plus 5 minus 5. Maybe let me write down. Minus 5. That gives you plus 5. That is the correct beginning. And then the radius is always attached to the trigonometric function. That's what you should know. So it's going to be 11 multiplied by cosine t and sine t. Sometimes that's not how the answer looks like. From here, you can now find x equals 10 and minus 5, which, yeah, it's actually still minus 5. That is purely represents the center. This is how we know what the center is by just looking at it. Oh, it's centered at 10 minus 5. That's it. Plus and plus. And then radius is very explicit. It's multiplied by the trigs. Whatever the trig number, whatever the number in front of the trig, that is how far the frequency is going Sine, cosine are usually from -1 to 1, but if it's multiplied by 11, now it's from -11 to 11. That's the frequency of the sound, of the wave, of the circle, how big the radius of the circle. Now it's times 11, so it's 11 times bigger. And then 10 and -5 tells you that the shift. Remember from the pre-calculus class, this is a stretch. TCH. A stretch is when its function is multiplied by something. But then this is a shift, vertical or horizontal shift. For X, it is horizontal shift. For Y, that's what it's a vertical shift. So that's why the center is shifted 10 units to the right and 5 units down. Does it make sense? Instead of being a 0, 0, the center was shifted 10 units to the right and 5 units down. So it's -5. Center minus. The center is 10 and -5. -5. And then this, how big the circle is. 11 units radius big. What do you think about that? Almost done. Only 2 things left. Only 2 things left. That's amazing. That's how good this review is. I'm actually very satisfied with that. Almost done. What are 2 things missing? You remember? Yes. What is 2 things we did not cover yet? 4 and 5. Example 4 and example 5. For the function for x equals, for example, 2 sine 5t and y equals 2 cosine 5t. And the t is between 0 and pi, for example. Why not? 2 questions left. Question 1, that's what I put in the quiz. Find slope at t equals pi. Slope is dy over dx. At, that's the bar, t equals pi. That's the notation when the third variable is involved, or a parameter. In the literature, you will see t equals 5, maybe mass is 30 kilos or 30 pounds, and gravitational forces is 9.8, if you remember. So you will see this notation in the books a lot, in physics specifically. The engineering guys, you will have that, people. So, guys and girls, people. And B, well, what if I want to see? So this is a circle, right? But at some point, we stop. At 0 to pi, we'll decide to go only halfway through, instead of 0 to 2 pi. So I want to find arc length. So how long this path took me to go? Arc length, or the length of the curve. So if that was a person walking, I want to know how many miles was that, right? Whatever. So, or the length of the rope. So let's find it. Solution. That means you need to know the formulas. Dy over dx. Find the second equation first and differentiate it first. Derivative of 2 cosine 5t goes first. That is important. That is important. Equals. Now, 2 stays as 2. Derivative of cosine is minus sine 5t. Good enough? It's also 10 in front. Where did you get 10 from? Why? Because it's 5t, exactly. Don't forget to multiply it by 5. So 5 times 2 gives you 10, perfect, exactly. So, chain rule. Like if you're questioning where this came from, that is chain rule. C calculus 1. I have lots of good videos about chain rule because that's the most confusing part in calculus 1 for students. Calculus 3 students told me they're still afraid of chain rule. Every time we have chain rule in calculus 3, they're freaking out. So I made lots of very good YouTube videos if you want to check them out. See what I did? Instead of writing the formula, I just jumped into differentiating right away. Remember, you don't integrate, you differentiate. Derivative of cosine is minus sign, and then multiply by the derivative of the function inside, and the function inside is 5t, and derivative of 5t is 5. Epic. Now you can come down and just write down derivative of the first function, which is x. That one goes to the denominator. Derivative of sine is cosine, so 2 times cosine 5t, and you don't forget the chain rule, which is 5 as well. This is the answer. You just simplify. That's it. Oh, we just plug in pi also. I forgot about that actually. Minus 10 sine 5t and plus 10 cosine 5t. So some people are lazy. They did not rewrite. They put the bar and t equals 5. That for the reader, it makes sense. At, not 5, pi. We're plugging pi because that's what's requested at the very beginning. We're plugging pi. Well, sine of 5 pi, unfortunately, is 0. Or not unfortunately, so everything is 0. If the denominator is 0, that will be upsetting. But it's not. So 0 over something is 0. So the slope is 0. The slope 0 means the function is horizontal at that point, or the tangent line at that point is horizontal. What does it mean? It's possible that at that point, the function has maximum and minimum. And here it is, you see, at pi. Does that make sense? At pi, 5 pi is, yeah. Multiply 5 out front. The question is, is there going to be a point where we need to find second derivative? Not for this case. Second derivative was like this in the homework to practice product rule. Like, why? No. The second derivative has nothing to do to parametric equations. That's why that question was just to like piss off students in your homework. I clearly remember the not smart at all. Whoever coded it just really had like too much time in their hands. So second question is arc length, L. That's one that requires the formula from A to B, gigantic square root, a derivative squared in any order squared, and plus derivative squared. That's the best way to memorize it. I like to say it out loud. You can say it out loud if you want in the exam. I don't mind. So order doesn't matter. Negative signs go away because of the square. So you can just find it right away. We give you the A and B. In calculus 3, you will have to find A and B. And actually in 9.3, 9.4, next chapters, we'll have to find A and B. Now we give you everything. So you just need to know the formula. Square root. Some kind of derivative squared plus some kind of derivative squared. I don't even care about the order anymore. 2 sine gives you 2 cosine times 5. I could just actually use whatever we have here. 10 cosine t, everything squared. Don't forget, not just cosine squared, everything is squared. Plus, now minus 10 sine gives you still plus 10, so I don't even care about that. 10 sine 5t, everything is squared. The thing is, the t at the end. The thing is, if you mess up on the test and you forgot the derivative of cosine is minus sine, which is here, I will not know that because square cancels out minus. So even if you actually did the mistake, I will not find out because the answer is correct. So that's actually a good thing. Can we integrate that? Because it's actually asking you to integrate, right? It's integral from 0 to pi, square root of 10 squared dt. Did you know how you get this? So it's not a gigantic square root anymore. It's a small square root. Tiny square, I would say. It's tiny square you can have. So how did I get that? I have 10 squared cosine squared t plus 10 squared sine squared t. Factoring out 10 squared, it gives you cosine squared t plus sine squared t. But cosine squared t plus sine squared t is 1. So it's just 10 squared. But everything is inside of the square root. That's what. So my charge left, 30%, not bad. Does it make sense what I just did? So the answer follows right away. If you have integral with just constant inside, the answer of this integral is that constant, which is just 10, times the length of the interval, pi minus 0. So the answer is 10 pi. Thus, therefore, summary, in conclusion, the length of the r from 0 to pi on this curve, which is a circle, is 10 pi. Isn't it cool? By the way, do you know what the shape of the circle is? So this is a circle centered at 2, 2. So radius is in front of it. Yeah, centered at 0, 0. Radius is 2, not 5. And it's going through the circle 5 times faster than the usual one. The usual circle have sine t, cosine t. This one is 5 times faster, scrolling around like so, very fast. So, but this, it's still centered 0, 0, radius 2. How do I know that radius is 2? The number multiplied by the trig function is the radius. And then since there's no shift, there's no x minus 7 or no x equals 7 plus 2 sine, then the center is 0, 0. That's all, folks. Let me check the questions from the chat. And then there was like a request for the problem. 41 or 44? I think 41. Oh, you want to go over that thing? Yeah, I remember that. So any questions? That's all. So like if you think you don't have questions and stuff like that, you can feel free to go. See, usually takes 2 hours to explain all this and practice. And I'm posting the key for the quiz right now. So you will see what we want. The last quiz is priceless as always. The last quiz have lots of important information. So, and so on. So people are asking about this question, which we have number 41. I will show you number 41. Number 41. Thank you for coming. Good job. Number 41. That's from the review. It says x equal v sub 0 cosine alpha t. Y equals v sub 0 sine alpha t. Welcome to the physics world, when there's lots of parameters with lots of unusual names. -1. People who like computer scientists, I don't need this, I don't like physics. Biomedical engineers, I think, don't have lots of physics. Or maybe they do, I don't know. Yeah, good point. So the most important, I see lots of letters. The higher math and science and STEM you go, the more letters you see versus constants. The most important is what they're going to say about all of this. They say x and y are variables, while g and v sub 0 are constants. They even give you that g is 9.8. It's a gravitational force, gravitational constant. So that means I can actually take colors and indicate, well, alpha is the angle, yeah. Indicate the only variable is t. T is the variable here. So if they ask me to find the derivative solution, so find dy over dx, then I know what to do. Dy over dx will be, look at the second equation first and take the derivative, and you have to think about that with respect to t, So if I have, oh, that's not, t is multiplied outside. That's actually quite important. Oh, okay. So cosine alpha and sine alpha is not a function. It's not a variable. If alpha is a constant too, which I think I should have pointed out, then I don't have to differentiate cosine and sine. Only t is a variable here. So it's like 10t basically. All this thing can be 10 or -17 or whatever it is. So I'm looking at the second equation first. It has v sub 0 sine alpha times t. So it's going to be v sub 0 sine alpha. That's it. Minus 1/2 g times t squared. 1/2 g times 2t. 2t. That's what's happening here. Derivative of t squared is 2t. 2t. Now I'm looking at the first equation and differentiating that. The first equation is giving you v sub 0 cosine alpha, because it was multiplied by t. That is the answer. And now they will ask you to plug numbers. They say, well, now we have that v sub 0. Is it like velocity or something? Oh, it's maximum height, something, something. Yeah. 200. So plug v sub 0, 200. Alpha is the angle, 30 degrees. Okay, plug 30 degrees, but don't plug 30. Plug in terms of pi. That's important. Or plug 30 when you use calculator for 30 degrees. And t, find for t, and you find for t 100 over 9.8, stuff like that. So they ask you to solve for t if we have left-hand side. Left-hand side was 0 because they said it's going to be maximum height. Maximum height means slope is 0. Slope equals to 0. So something is going up and then go down. Temperature, direction, throwing the stone in the air, blah, blah, blah. Whatever is at the maximum has slope 0. But slope is derivative, dy over dx. So that's why we found it. So you say 0 equals blah, blah, blah in terms of t. Solve for t. And you solve for t with given numbers. And then the t gives you time. Apparently it's 10.2 seconds. At 10.2 seconds, the object reached its maximum height. That's number 41. Let's see.
Wait, how did you get 10?
No, that was just a stupid example. There's no 10 here. Don't write it down. I was just saying as an example, sometimes I explain calculus 1 like this. This in yellow is a constant. So like what kind of constant it can be? 10 minus 7.3. The most important is that's how you see it in your mind. Constants times t. Derivative of constant times t gives you that constant. So that's what I meant. Don't write it down, but t totally confusing. Just a second. Let me stop this amazing recording. Like and subscribe.